Hello, this video tutorial is going to be designed to help you with the kinetic energy and then also potential energy. So let's dive right in and let's first talk about the differences between the two. So kinetic energy deals when an object is in motion. Okay. Now, potential energy deals with the stored energy in an object. Okay, so an object in motion can still have potential energy. Okay, but potential energy is stored. Okay, so imagine you've got a dude and he's holding up a ball. Okay, when he's holding it, there is no kinetic energy because the equation for kinetic energy is 1/2 mv squared. So when he's holding it, there's no velocity. So when there's no velocity, it's zero. You've got no kinetic energy. Now it does have potential energy. That looks awkward. Let me just go ahead. There we go. He's got parachute pants on. So potential energy is given to you as mass times gravity times y, the y being your height relative to some reference. So in this case, let's make our reference be the ground. So the potential energy relative to the ground, ooh, straight line. Let's say this is 2 meters off the ground. Well, the potential energy of the ball would be the mass times the gravity times 2. So let's say the ball has a mass of 1 kilogram. Okay. When he is holding it, the potential energy would become 1 times 9.8 times my height, which is 2. So my potential energy would simplify down to 19.6, and the unit on that is joules. Now, when he lets go of the ball, he has instantaneously he has no kinetic energy. But what happens is as the ball falls, it gets turned into kinetic energy. The potential energy transforms into kinetic energy until right before the ball hits the ground, it's all kinetic energy because your height is 0. Okay? So let's say I want to know the kinetic energy just before the ball hits the ground. In this case, you would use the conservation of energy. KE1 plus PE1 equals KE2 plus PE2. Okay. So initially, we have no kinetic energy. Gone. And where I want to know, in other words, where y equals 0, I've got no potential energy. So this becomes potential energy, which we found at the beginning was 19.6, is how much kinetic energy I have at the bottom. So all of my potential energy gets converted into kinetic energy. In other words, the total mechanical energy, which at any point is just kinetic plus potential, total energy is conserved. So initially, I've got no kinetic energy, but I've got all potential. So that means my total in this situation is 19.6 joules. That is my total energy. Okay? So at any point on here, if I calculated the potential energy, I could solve for the kinetic energy. Now, let's say I wanted to know the velocity of the ball right before it hit the ground. Well, kinetic energy is just 1/2 mv squared. So I substitute that in, and I solve for velocity. So I can plug in my mass is 2, or excuse me, my mass is 1. So 19.6 equals 1/2 times 1 is just 1/2 v squared. So I'm going to multiply both sides by 2 to cancel the 1/2 here. So 2 times 19.6 is going to be, let's see, 12, carry the 1. 2 times that makes 19, carry the 1, so 39.2. Okay. So that would be v squared. So then lastly, I would square root both sides. Okay? Now, that's if I wanted to know the velocity of the object. So let's say you're given an example and all you have to find out is the kinetic energy of the object. So let's say you've got a baseball with black stitching, and it's got a velocity of 10 meters per second. And let's say the ball weighs 131.5 grams. And I want to know the kinetic energy of the ball. Okay? Well, kinetic energy is, again, 1/2 mv squared. V squared. Now, m is mass. This mass over here is in grams. You have to convert any mass that you're working with to kilograms. So to convert that, 131.5 grams, I need to get rid of grams, so there are 1,000 grams in 1 kilogram. So I'm going to divide this by 1,000, where there's 10, 100, 1,000. So this thing weighs 0.1315 kilograms. So I take this and I substitute it in for my mass. So kinetic energy is equal to 1/2. My mass is 0.1315. And my velocity is 10. So, and it's v squared, so it'll be 10 squared. That's a parentheses. So I've got 100, which is 10 squared, times 0.1315 times 1/2. That gives me a total kinetic energy of 6.575. And the unit on kinetic energy is joules. Okay? So that would be a pretty straightforward problem where I just ask you to solve for the kinetic energy. Okay? So that is the gist of kinetic and potential energy. So just know that if I ask you for potential energy of an object, it's going to be its mass times gravity times the height, gravity being positive 9.8. If I ask you for kinetic energy, it is going to be 1/2 mv squared. So both of these cases, the mass is necessary. The mass needs to be in kilograms, and the units for potential energy are joules, as are the units for kinetic energy.